Hello, hello everyone.
Good afternoon.
Good afternoon. Waiting
Hello.
for others to join us.
Um, Hello, Professor.
Hello.
Uh, yeah, we just I just want to ask a question about the project.
Oh yes, please. Yes, by all means, yes.
um, Last semester we had an option to choose between the between a few last labs and making a project. Maybe it makes sense to allow for something like this semester too, because the project looks a bit more complex than the one we offered last time.
Okay, let's see. So could you please first of all remind me of the last semester? You said we had a choice between having a project and what?
And making the labs.
And making the labs. Okay. Um, we definitely can do that. But in general, what we have been doing so far was largely belonging to both, actually. It was related to the project and to making the labs. Okay, maybe of how many labs did you have so far?
Oh, let me check.
5.
5. Okay.
Oh, okay.
Of those 5, I think you had one related to examining smart contract security, right?
Yes.
Yes.
A recent one. But others were really about implementing our coins. So first of all, you implemented a coin. Well, the first labs were about setting up the development environment, right? Then you implemented an ERC20 coin, and you implemented an ERC721 coin, right?
Not actually, and I just wanted to make clear some problems that we faced during the labs.
Okay, yes, please.
Like after the Tuesday's lecture, we had the lab, and I explained to Hamza what is the point of like many students are not really satisfied with the what is going on with the course because of lack of communication, as I think. And
Excuse me, a lack of communication with whom?
I think with everyone in this case. For
Sorry,
example,
sorry,
Hamza, even Hamza thought that, for example, in lectures we are explaining, we are discussing what is the concepts of smart contracts, how to write them, and what is the what is solidity, v3, web3, etc.
yeah.
So he is highly relying on those concepts, but as you know, we are discussing mostly, for example, how exchanges are working, what is the currency, what is the like all those more theoretical things, and
I see.
many
So
people
when you
face.
started, okay, when you started doing the labs, you felt a little bit unprepared about how to, for example, program Solidity, even the simplest examples, because,
Yes,
okay,
despite the fact that we had a course actually about blockchain and we had some labs about
examples of
Solidity
Solidity,
previously, and still many students
I see.
at first they feel not really prepared to solve this task during the lab time.
Okay, we'll
And
rectify
then,
this. Okay,
despite the fact that actually those labs are really simple, and most of them may be solved in 30 minutes, it usually takes more than 2 or 3 hours to solve in a group, because some of the students still don't really get the basis. So
okay.
before moving to year C20, before you moving to year C700 something, it is
It would be better to
before
cover the
implementing
basics
it,
of Solidity.
we should understand what is the purpose of this. Like,
Okay.
why are we using these contracts? Why don't we implement ourselves? Those concepts were explained to me by Rim, for example, but I haven't got it from nor lectures and not from labs.
Could you please elaborate on this a little bit more? Because so what was it? Is a very important point to hear actually. What was really unclear? So the purpose of smart contracts in general, the purpose
Not
of
the purpose of smart contracts. For example, let's imagine the last situation, right? The last lecture about mm, the
about
exploiting
vulnerabilities.
the about the vulnerabilities in a smart contracts.
Last lab, not last lecture, but last lab.
But you also said about hard fork of Ethereum,
Oh yes, yes.
and this is like this part was like a short piece of information that there occurred some problems in Ethereum network that allow to have some vulnerability to happen. And after the lecture, the second point is that Hamza is very relying on that we are experienced enough to get everything by ourselves. But many people think that we should be able to solve this task based on the knowledge that is provided during the lab and lecture time. But actually, we have to Google and learn by ourselves. And we are missing the point that why do we need to visit the lecture? That is why only 6 people are here out of 20, because they don't see a point of visiting the lectures if they could just see the task, read it in the internet, because the description is not provided in a proper way, the explanation, you can't really like get those knowledge in an easy way from lectures and labs. And that is why they are just decided, okay, I will Google it during the lab time and will submit the lab by based on knowledge that is learned by ourselves.
I see your point. Good thing. So first of all, let us do the following. So first of all, because you see, for me it is also important on the one hand to give you all information you need, on the other hand not to repeat some kind of information which you may think is just something which you can just read from technical specifications and so on. But I understand that you and many others would like, for example, a very detailed coverage of solidity in our lectures. Is it true?
Yeah.
Great, great. So what I suggest, I was also thinking about that. What we will do, we will today complete the discussion of why I'm discussing these DEX features. Simply because we are going to implement DEX in our labs. The first labs were indeed reasonably simple, and this was just, I would say, to get. It was not about just smart contracts programming in general. It was rather about how to get those uh, instruments in your fingers. So how to use any development environments, how to deploy a smart contract, how to compile and deploy it, and so on. But then I think today those who miss the lectures can anyway access them on YouTube, so everything will be there, obviously. Today we will complete the discussion of the DEX features, because then we will need to implement DEX. As I said from the very beginning in the first lecture, we're implementing coins, and then we implement DEX, a distributed exchange, which really exchange our coins, right? Which will be used to trade to exchange our coins. So I think today we will complete this type of discussion. And next week on Tuesday and Thursday, we will start examining what we will need to discuss now. For example, solidity in very detail. But you have now been familiar already with multiple development environments for your smart contracts. So my question is, so what have you opted for eventually? So for example, Solidity, Viper, or whatever. I can cover both, but let's discuss now what you would like to hear. I would
Solidity.
probably recommend Solidity. What are your thoughts?
Yeah, Solidity, because we've used it during the last labs, and it will be much easier to stick with this, with a single technology that.
Okay, okay. Because originally the idea was a bit different from that, that everyone would be using the technology they want. Okay, Vladimir says, I'm interested in Substrates Inc. Smart contract language. Okay, um, we may discuss other languages as well. Perfect. So please, don't be shy. Put in the chat everything you want to hear about, and it is a very good thing that you are discussing this now, so we can make all necessary adjustments. Perfect. So um, this one. What else? Would you like to hear about Viper, for example? We'll definitely start with Solidity because it is the most uh, not just widely used, but I think very well designed modeling language for smart contracts. So uh, it is a very, as I mentioned, a very convenient model, not just to implement smart contracts, but to think about smart contracts. So that's definitely the number one. If you would like to, we will make a special session on substrate smart contracts. Okay, fine. Anything else? Obviously, after Solidity. Okay, so the plan is we finish discussing DEX architecture today, because without that we wouldn't be able to implement anything. And when is the next lab? When is the next lab for you? Is it today?
Yeah, yes, seems like that.
Okay. So from next week, we will cover. It may require 2 or 3 lectures. Yes, actually, WebAssembly as a language for smart contracts. Perfect. Yes, it is a very good idea. A Clang-based compilation infrastructure, which which I personally like very much. Good. We'll discuss. Thank you, Rim, for the suggestion. We'll discuss that. Ink is also a very good idea because it is built on top of Rust, and it is a kind of functional language. It is a very good idea. So fine. We'll discuss that. And about your idea of having a choice between doing labs and doing a project, I think today would be the last lab anyway, which is not project related, because the original labs were about just introduction into various topics in smart contracts. But from that point on, from the next week on, we will have labs which are really doing your project. So there wouldn't be any short-term task. Just do it now and you submit the lab. It will also be part of implementing eventually the DEX. How do you feel about that? So that was the intention.
Will it be a group project or not?
I'm in favor of group projects. Why? Because we have already implemented coins in group projects. We don't need that many, a huge number of coins. So if there are 20 of you and you are divided into, let's say, groups of, let's say, 4 people on average, then we have about 5 implementations. That's, I think, about the ideal number. And the final exam in that case, would be both some theory and, most importantly, the defense of the project you have implemented. So from the next week on and until the end, there will be a project on implementing our DEX, or more specifically, N DEXs, where N is the number of teams, the number of groups you form. So that was the intention. How do you feel about that?
I
Okay.
can't say from the all behalf, but from mine at least, and close people to mine to me were positive to this.
Very positive. Okay, I think we will discuss it in our Telegram channel as well. But I perfectly take your point that we need to spend more time. Just I was wondering whether it could be a bit, I would say, boring, mundane, etc., etc., etc. But we'll definitely spend more time first on Solidity, then on Ink, and then on web assembly, discussing that. That's perfectly a good idea. Are you happy now with our arrangements? Any other thoughts, any other objections, proposals, ideas? Okay. So in that case, let us continue with, we'll discuss some further details which you need to know in order to be able to build a DEX. So basically we're discussing our domain, what we really need to know in order to implement it. We need to understand how it operates, okay? I'm starting our whiteboard as usual. Okay, so let us recall what we were talking about on Tuesday. So first of all, we introduced the notion of the instrument. And then we discussed the structure of the order book. Bids and tasks. Orders. And how the orders are placed in the order book. So let us, this is a very important thing, let us recall once again. So when a new order comes into the order book, then what can happen with this order? So there is a new order, and obviously our DEX as a smart contract will have a method which is a submit order. So by invoking this method, the user would be able to submit a new order into the order book. So what can happen when the new order comes? It can be classified into passive or aggressive. You remember? So if, for example, side is buy and price, what is important, first of all, price is, first of all, finite. Well, by finite price, we agreed that we would say price is positive. So we do not allow negative prices, and zero price means no price. And price is positive, and price is for the buy is strictly less than the minimum ask, or other way around, side is sell, and again price is finite, positive, and price is strictly greater than the maximum bid, then the order is, what can you say about this order? Order is passive. And it is passive, it is placed in the order book. It's not just the theory, it's what you will have to implement when you implement a DEX smart contract. Where it is placed. If side is buy, it is placed in bids. Side is sell in asks. We have discussed, yes, 2 days ago, that placing of the order is actually placing of, first of all, there are two maps. One map gives you all orders by order ID. So, so placing in the order book means, first of all, order ID is automatically assigned. Second, what happens second? Second, we have a map where orders are stored by order ID. You remember we have map which I would call, let's say, all orders. Which is a map from order ID. Order ID is just a long integer. To order itself. What is order itself? It is a tuple we have seen last time. So order is placed in this map. And finally, not the order itself, but order ID is placed in the corresponding side of the order book, how we have seen it last time. Order book side. So that happens when the order is when the order is passive. Now let's consider what happens otherwise. Otherwise, by the way, means that first of all, the price might be not specified. So price is 0. That's one situation. Or price is not 0. And side is buy, but the buy price is high. What does it mean high? At least the minimum ask. Or price is positive and side is sell, and the price is low enough, so the seller agrees to make a low enough price which is at least the maximum bid. This means aggressive order. And moreover, this situation with price equal to 0, it is a so-called market order for which the price is not specified at all. How it works, we will see now. No price, right? And these situations are so-called aggressive limit order. Okay, so that's fine. Now you can see what is happening. So there are asks and bids. And there are order IDs arranged by price level. Okay. So whatever. So whatever. 1500, 1500, 02, 02. I don't know what instrument is it, but it could be like Ethereum to USDT, for example. And there is always a positive bid-ask spread. So in the order book, it is always minimum ask, as you remember, is greater than the maximum bid. Or equivalently, bid-ask spread, which is minimum ask minus maximum bid, price of course, it is always positive. So if an order which would violate this requirement comes into the matching engine, it is not placed in the order book at all. So this is called an aggressive order, which is not placed, simply not placed in the order book. What happens instead? Instead, it gives rise to a sequence of matches. And this sequence of matches you will have to emulate, not to emulate, but really to implement. So aggressive order results in matches. Iterates. Let us first consider the situation. I would like to stop here for a second and ask, so far everything should be perfectly clear, right? Or any questions at this point? All is fine?
No questions yet.
Okay. So let us consider how this actually works. So suppose that there are 3 orders. This is some instrument, not our coin, but prices like 1500. They suggest that it is Ethereum to USDT, for example. It doesn't matter. So suppose that there is an aggressive buy order, and here at 1502 there are orders A, B, and C. So the order A, order ID doesn't matter, some ID A, doesn't matter which. Price is obviously 1502. Quantity, let's say, is 1. B with some ID B, and this is enough, obviously. Price is same, 1502. Quantity is 3. And C, ID C, same price, and quantity is, for example, 5. They are in this sequence, so A, B, C, which means that A came first, historically, just in the time sequence. C came last. Okay. What happened then? Suppose that there is an aggressive order D, obviously those A, B, C, all of them have side sell. Because the side is sell, they're here in the ask part of the order book. Okay. Now comes an aggressive order D, and that aggressive order it gets assigned some ID D. Let's say the price is 1503 and the quantity is 10. So what does it mean? Side is buy. So someone wants to, what does it mean, this aggressive order? First of all, why do we know that it is aggressive? Because the side is buy and the price is 1503, which is greater than or equal to, actually greater than the corresponding minimum ask. So the order cannot be simply put into bids. If the price was lower, at least below 1502, then this order would be placed into bids simply. But the price is high enough, so it would intersect with the opposite side. In another book, this cannot happen. So this order, because the price is greater than or equal to 1502, is deemed to be aggressive. So it starts matching with the orders already there in the order book. So someone agrees to buy 10, in this case Ethereums, at the price 1503, and there are offers for sell, precisely those A, B, C, and possibly some others. Then there is a price 1503, 1504, and so on. And there are some Ethereums for sale. So the order, the aggressive order, starts traversing the order book from the bottom of the book into increasing prices in this case, and at each price level from the earliest orders to the latest. So what happens? First, it generates matches. First, D is matched with A, and so we really got a match. AD. A was already in the order book, and now it is matched with D. So what happens in this case? A was for the quantity of 1. So 1 Ethereum was for sale in the order A. But D wants 10. So okay, a match occurs between A and D for the quantity of obviously only 1, because A was only 1 Ethereum for sale, right? But now D has unfilled quantity, which was originally 10, but now it is 9. Unfilled quantity of D is now 9. Then it continues to match at this price level with the historically next order, which came at this price level after A, which is B. Then there is a match between B and D. Quantity is the maximum. In general, the quantity is the maximum of quantity B and unfilled quantity of D. And the unfilled quantity of D is 9, and therefore B is only 3, and therefore the quantity is 3 here. And as a result, unfilled quantity D is now 6. Okay? So 6 is still unfilled. And for that reason, D continues to match. And then several situations are possible. The next match is CD. Again, quantity is the maximum. Oh, sorry, not the maximum, obviously, the minimum. Apologies for that. The minimum of the quantity for sale and the unfilled quantity. Therefore, it was 3 here. Then it is again a minimum of the unfilled, the quantity C, which is 5, and the unfilled quantity, which is 6, and therefore it is 5. So all these traits, matches or traits, they occur at the price 1502. So those A, B, C were put for sale at the price 1502, and indeed they are sold at price 1502 to the aggressor D. D being the aggressor who matches again those prices. But the unfilled quantity of D is still not 0. We still have 1 unit unfilled, all right? So what happens next with D? There would be two situations. One situation, it depends on the price of D. One situation, suppose that the price of D, I am not putting it here into the drawing, but let's discuss. The price of D currently is 1503. But suppose that the price of D was 1502. What would it mean? It means that D would not agree to buy Ethereum at a price more than 1502. So 1502 would be the maximum price the aggressor agrees to buy at. So in this case, it wouldn't go to the subsequent price level 1503, and one quantity, one unit of quantity would become unfilled. Okay? Let's say if price of D were 1502, then no more matches happen. Unfilled quantity is 1. Let us now just discuss. So what do you think happens? So an aggressor came, wanted to buy 10 Ethereums, but at the price no more than 1502, in that particular example, could not, because at the price 1502 there are only 9, 1 plus 3 plus 5, so altogether 9, A, B, and C, altogether 9 Ethereums available, and D has a limit price for it, so it does not allow itself to go higher than 1502. So what do you think happens with the unfilled part of D? Any ideas? Please,
It
your idea.
stays it stays unfilled until some other order will come to fill it in.
So first of all, you say stays. D with the quantity of 1 stays in the order book. It just, we wouldn't say stays. It is much more specific thing which happens. It is put in the order book. The remainder is put in the order book. But at which side? At buy. So basically what happens in that case is that the buy side is extended. You see, the level 1502 is not there anymore. So 1502 is completely demolished, eaten up by D. So then the order book becomes a new one. So asks 1502 is deleted. So asks start with 1503. So there is something here. And now there is this D in the bids at 1502, which is placed in the order book. And then there are all those previous bids, for example, at 1500 and so on. So these are existing bids, and D becomes a new bid. Why new bid? Because it was in order to buy. It couldn't buy the full quantity. So it not just stays, but it stays in a very well-defined place. It is placed at the price level 1502 in the order book. And that's a new bid-ask spread. it used to be between 1500 and 1502. Now it is between 1502 and 1503. So it is 1 here, whereas it was 2 here. So the order book, after this sequence of matches, the order book is again stationary and consistent. Now the minimum ask price is 1503. The maximum bid price is 1502, and that is made of D. Okay, so that's what happens in that case. There is another possibility that we would say, there are many possibilities actually, but we're not probably going to implement all of them. There is another possibility that, what else can happen? What do you think? Any other reasonable idea of what could happen? Another possibility is that the unfilled part of D is simply cancelled. Can it happen? Yes. Unfilled part of D is cancelled. So that's case A, and that's case B. In case A, that is our order book. In case B, it would be a slightly different order book. So asks would be, again, starting from 1503 up. So these are asks. But because the unfilled part of D is cancelled, there is nothing at 1502. And then there is a wide bid-ask spread of 3. And then there is an alt, there are some alt buy orders at 1500, and then 1499, and so on. So that's what happens in case B. So how do we know what happens A or B? You remember then when the order is submitted, there are flags in the order. So A or B occur depending on the flags in the order, and that's what we have to implement. Everything we are discussing now is going to be implemented depending on flags in our order. There was a flag which was called time and force. I briefly mentioned it. Time in force. So let us discuss possible values of time and force, and we'll think whether we need to implement all of them or we need to implement maybe a subset of them, because typically there might be quite a few different time and force flags, but I will explain some most commonly used ones. So what do we know about time and force? Motif. So the first one is called GTC, good till cancel. Let's say this is a default one. Probably. Maybe not. We'll see. But let's say we'll discuss whether it is a good default or not. This corresponds to case A. So if time in force is, so this one, if time in force is GTC, then the unspent part is placed in the order book. Unfilled part is placed in the order book. And because it is good till cancel, for how long do you think it remains in the order book? If we call it good till cancel.
Till cancelled.
Till cancel. And for cancel, you already remember from our discussion on Tuesday that we have an operation which is called delete. Cancel is delete. So the order is explicitly removed. There might be one problem with this approach in a context of our smart contract. What do you think? What kind of problem could you anticipate if we make good till cancel a default? It still doesn't mean that we can't do that, but what can happen as a result? What do you think? Then there would simply be too many orders staying in the order book. So people submit and submit and submit and submit orders into our order book. And obviously, because it is a smart contract, and the smart contract and its state live in the blockchain system, in the Ethereum blockchain, then this means that maps representing our order book grow larger, larger, and larger. So we may eventually have a very large number of orders staying in our order book and not going away. The only way how they could go away is that there is an opposite aggressive order which eventually matches with this one. Maybe that's okay. Maybe that's okay because we, in any case, we are storing the whole history of transactions in our blockchain. So yeah, there could potentially be large maps here, very much like ownership maps in ERC20 in any coin or token. Could be large, could potentially be large. So never mind. Still, that may or may not be a problem. I think we'll nevertheless implement GTC as our default. Another one is typically called, is more typical for fiat exchanges, but for crypto exchanges it is quite popular as well, which is called date, which means that it is still case A, but the order not necessarily this remnant, unfilled remnant of an aggressive order, any limit order actually is automatically deleted after 24 hours from insertion. From insertion to the order book. This is probably a good idea because the owner of this order can make sure that way that there are no old unneeded orders remaining in the order book, which can fire up at some point. So for example, you put an order, you have forgotten about that, the order was not filled initially, it came as a passive order. For example, you would like currently to buy Ethereum for, I don't know, 1400. So somewhere in the depths of this order book at the price 1400, there would be your buy order. And then you forget about it, and then the price of Ethereum really drops. So the order book comes to this level 1400, and then your order fires up, and you already forgot about it, and you probably don't need it at 1400. Interesting question. Why, from the economic point of view, you may think that you wanted it, for example, at some point and you do not need it at another point? Because when the price drops that much, there could be a downward price movement, and if your order is filled, then, for example, Ethereum becomes cheaper and cheaper and cheaper, and you don't need it anymore. So anything can happen. So having auto cancellation, auto deletion, for example, after 24 hours, a day, time and force is probably a good idea. But what kind of problems do you see in this case? If, for example, the order type is day, what do you think?
Smart contracts cannot be executed by themselves. So
Yes. So
situation for someone
how could we set up a timer which would really allow us to go through the timestamps and eliminate those outdated orders? Strictly speaking, no way. So what we may do the following. This is a perfectly valid approach. You see, if the day has expired, but there are no transactions in this order book at all, so no order submitted or deleted or aggressive order coming, nothing, okay, then it is completely normal that an outdated order stays in the order book. That's quite okay, because nothing happens with the order book anyway. The order is passive, it is passively staying in the order book, that's fine. But when a new transaction, any new transaction, for example, new order, delete order, and new order being passive or aggressive, come into the order book, then we would probably first need to re-examine the timestamps of all existing orders before doing anything else, drop those which have already expired, and only then decide what to do with the new order, whether it is going to be passive or aggressive. If passive, then where to put it to. If aggressive, then what it is to be matched with, based on the order book, with outdated items removed. Which is probably, not probably, but certainly a valid approach. But this means that it is computationally more intensive. And what does it mean, computationally more intensive, in terms of Ethereum? Ethereum computations are not free. You remember? Ethereum computations require what? Gas. So running this type of DEX would require more gas from the distributed exchange provider. All right? That's one thing.
Excuse me.
Yeah.
Why does it require more gas from distributed exchange provider and not from if well if we have to go through this map when some order is made, so the person who made the order will pay for that traversal. As I understood.
A good point. So who would, in this case, when the smart contract is executed, a good point. So who would be paying for that? Yes, you are right. It is the initiator, precisely. It is the initiator of the transaction who sends a transaction towards our smart contract who would need to pay with that. Yes, you are right. So it is not our burden. You're absolutely right. It is a burden on the user. Perfect. Well, if it is a burden on the user, then it is acceptable. Thank you for pointing it out. Any other problems? I would imagine another technical problem that in order to make it more efficient, instead of a full search may be infeasible. Need some map of, let's say, expiration time to order ID. But the problem is, as you, I think, pointed out last time, that the maps in Ethereum are unordered. Ethereum mappings, are they ordered or unordered? From what you know.
What do you mean by ordered or unordered?
Ordered means, for example, expiration time is a timestamp. Timestamp expressed as, let's say, microseconds from some epoch. If we create this map, can we traverse the keys in the increasing order of the key value? When we traverse a map,
I believe
ordering
we
of keys
cannot
is guaranteed or not?
well, I believe we cannot traverse a map at all because in Ethereum, as I know, uh, for example, if we have a map from some unit 256 bits to some other value, when if we try to get a value of a key that has not been set, we will get the default value.
Okay, okay. So in that case, it actually means that the map is unordered, definitely, because if the map is ordered, then you can traverse it. And it is just the property of such a map. And this is probably unimplementable. But we'll see. One way or another, we would need to be able to implement a traversal, whether efficient or not. Even if it is not no such a map, then we would need to traverse bits and tasks. And traversing bits and tasks, we still need to somehow to traverse them also. Some kind of traversal should be available. So let us put a question mark here. So how to do it, we'll examine when we discuss Ethereum features in more detail. But there must be some way which would allow us to traverse whatever map. Actually. So, okay. So at the moment, before we dwell into into Ethereum virtual machine and Solidity detail, we do not really know how easy this would be implemented. So they may or may not eventually be implemented depending on how computationally feasible, first of all, and if feasible, how computationally intensive that implementation would be. But ideally, it would be nice to have day. Good till cancel is a must. So we'll always have a good till cancel. Whether we have day, we'll see. But there is yet another very important type. So once again, it is a default, which is called IOC, which is immediate or cancel, which is also called, there is another term, fill and kill. But the most common name for it is IOC. IOC means precisely that we are in case B. Part of the order not immediately filled is cancelled. Okay. And why it is important? First of all, yes, it may very well happen sometimes that you really want this type of behavior. Many people do. That's one thing. Another thing we discussed with you, that there are also market orders. Market orders. If you remember, what are market orders? Market orders are those with price being set to 0. All right? In fact, it is only a symbol that, price is 0 means market orders. In fact, market buy mean that the price is plus infinity. We say 0, but in fact it is plus infinity. It means that if we do a market buy, then the submitter of this order agrees to pay any arbitrarily high price only to buy the required quantity. Market sell, and market sell really mean that the price is 0, so as low as it would take. So the submitter of the market sell agrees to sell at any low price going tending to 0, just to sell. Even then, even with this, so here it means actually, any low value. And here is any high value. And it must be said that suppose that we fire up a huge market order to buy, for example, I don't know, for 1 million Ethereums, and there are no 1 million Ethereums in the order book. So this market order eats up the whole ask side, and there is still a remaining part unfilled. What happens? Market orders are by default IOCs. If it is a market, then by default, it is not possible to do otherwise. It is always IOC. So it is an error, not just by default, I would say it is always an error. It is an error if a market order is submitted and it is not an IOC. There may be some other time and force values, but I think we, for the moment, we can be perfectly okay with those three types, GTC, day, and IOC. And returning, stopping here, everything is clear. Are you all fine with this? Apparently,
Yes.
yes. Because we see, this is not just an abstract thing we're talking about. This is all functionality which we'll really need to implement as our project, which will be done as a sequence of labs starting from next week. Now you can say what happens, yet another situation. What happens, you see we had some branch unfilled here. Not yet explored. So first we considered what is the price were 1502. Now if price of D is, let's say, greater than 1503, and at 1502 there was an unfilled quantity of 1, going back into the order book, suppose that at level 1503 there is now order E. There is an order E and some others, but here there is an order E. And order E with some ID E. Price of E is now 1503. And the quantity is big. Quantity is 10. So what happens in this case? In this case, obviously, there would be yet another trade, or yet another match between E and D. For D, unfilled quantity is 1, so the quantity is of this match is the minimum of 1 and 10, and it is now 1, which means that now D is completely filled. And what happens with E? E is partially filled. E was a passive order, staying in the order book at 1503. E is partially filled. So the unfilled quantity of E remains 9. So the submitter of E wanted to sell 10 Ethereums at the price 1503, could not sell 10, because at that price only one aggressor so far remained who penetrated to the level of 1503, and being gradually filled while doing that, only one quantity remained to be, one unit of quantity, one Ethereum, remained to be unfilled, and that's why E was able to sell only one Ethereum at this price, at 1503. So eventually, what happens for the aggressor? The aggressor generated a sequence of, depending on the price, suppose that generated a sequence of 4 matches with A, B, C, E, E, and E. So let us sorry, let us examine traits more specifically. So what happens when a trait or match occurs? We'll need to implement it as well. At a trait or match. First of all, we will introduce a data type for that. So a match will be, so what is a match? A match occurs between two orders. And let us, for the sake of the argument, might be a good idea to have some convention on that. So first of all, when a match occurs, we will say order ID 1 and order ID 2, because the match was between two orders. Of those two, one is always passive and the other one is always aggressive, right? So let us make a convention that by order ID 1 in a match, it will be a passive one, and by order ID 2 will be an aggressive one. So the passive, it was already present in the order book. So it came earlier. You understand, OB in the order book. And the aggressive one was not in the order book. Once again, the aggressive order is initially not placed in the order book. It just starts matching and matching and matching. The remnant, the unfilled part, the remainder, the unfilled part of this order can eventually stay in the order book if it is not an IOC. But initially, when an aggressive order comes, it is not placed in the order book until we know what happens with it. Okay. Now, what else? If there is a match, there is a match or trait. So we'll use those terms, match and trait, interchangeably. So these are two equivalent terms. The third parameter in a match is a trait price. So it is a price at which the trait occurred. What can you say about this trait price? From what you already know about the mechanics of matching. At which price the trait happens? Please have a look. Please have a look at our diagram.
Price where intersection, non-empty intersection exists between.
Yes, but the intersection is between the aggressive order and the passive order. So when an aggressive order, for example, has a high price to buy, then matches with A, B, and C, they still occur at 1502 at passive price, right? So the trait price is always the price of a passive order. The aggressive order will go into higher prices to buy or lower prices to sell only if there is an unsatisfied unfilled remnant. But the current matches occur at the passive price. You encounter a passive order and you match at the price of that passive order. This is a very important thing to understand and to remember. So please think about these mechanics once again. And for the moment, we say that it must always be equal to the price of a passive order. So trait price equal to price of order 1. It cannot be equal to the price of order 2 at least because the order 2 may not have a price at all. It may be a market one. When a trade occurs, it occurs, basically, you are right saying that an aggressive order collides, in this case, with a passive order, and the trade price is the price for the passive one. What about the quantity, however? It is a slightly more complex thing here. There is also a trade quantity, and we can't say exactly what kind of quantity is it. We only know that the quantity is positive. It is definitely not zero, and we know that the quantity is equal to the minimum of aggressor unfilled, yet unfilled quantity, and the passive quantity. So I can only say that because I don't know what the aggressor unfilled quantity is. I know that the quantity is positive, and I know that the trade quantity is obviously less than or equal to order 1 quantity, again of the passive one. That's what I know. So these are the main parameters identifying a match. You may, if you want, assign a separate match ID to matches, but typically it is sufficient just to have a match with order ID 1 and order ID 2. Also, a very important property that with given order ID 1, order ID 2, there could be only one match. Because what happens? Either the passive order or aggressive order becomes completely matched in this match. So after the match, either the passive order or an aggressive order, or maybe both, do not exist anymore. This should be clear. If the passive one has a size smaller, let's say quantity of order 1 is strictly less than unfilled quantity of order 2. What does it mean? This means that order 1, by the way, what happens with order 1? Order 1 is completely matched, completely filled. I would still, I must say, not just quantity of order 1, but unfilled quantity, because it might be that the passive one was previously already partially filled by another aggressor. That's also possible. So pay attention to this. Unfilled quantity of order 1 is less than unfilled quantity of order 2. Order 1 is completely filled and then deleted. Other way around, if the quantity of order 1 is greater than the unfilled quantity of order 2, then order 2 is completely filled but not deleted. Please your attention. Why do I say that the order 2 is completely filled but not deleted? who can tell me why in this case the order 2 is not deleted?
Because it is aggressive.
Because it was not in the order book to begin with. You're absolutely right. Deleted can only be an order which was already in the order book. It was not in the order book. Aggressive order is aggressive. You're absolutely right. And finally, if they're equal, these two quantities, then obviously understand what happens. Both orders completely filled. Order 1 deleted. In this case, order 2, order 1 is completely filled. Order 2 is not completely filled. Order 2 continues matching. In this case, obviously, order 1 is partially filled. So the quantity of order 1 was greater. Remains in the order book. Sorry for my handwriting. Okay. So that's what happens with traits. It might be a good idea to record traits, all traits in our smart contract as well. So we would see the history of traits, and we understand, so everyone would be able to examine what they have been doing. And most importantly, when a trait occurs, so other functionality, we need to think about how to implement it. So keep log of all traits, in the smart contract. Clients should be able to, but that's a question. Clients should be able to examine the order book. How remains to be seen. Maybe not. Again, I say if feasible. And most importantly, when a trade occurs and when a trade occurs, it must be settled. It must be settled automatically by the smart contract. So what does it mean? There is a trade again, order ID 1, that's a passive one, submitted by A. So that's person A who submitted order 1. Order 2, order ID 2, that's a person B. for a certain price, for a certain quantity. Price and quantity are known. And the instrument, let's say, for the sake of the argument, currently is Ethereum to USDT. Or, okay. So, what does it mean? There is a match, okay. Do you think we're missing some information here? We recorded our trade, but now we need to settle it. So how can we say the instrument is obviously Ethereum USDT? There are two parties, A and B, involved. We know that one party had a passive order, another party had an aggressive order. But who was a buyer, who was a seller in this case? So A is buying this quantity of Ethereum, or A is selling this quantity of Ethereum. No one knows. So we need yet another flag, a very important one, in our match or order designation, which we omitted. Yet another one, which would tell us what to do with this settlement. So we put it, okay, my whiteboard doesn't work anymore. Or does it? Here we are. Apart from quantity, we need a Boolean flag, which I can say as, for example, aggressor is buyer. That's the Boolean flag. And now we can say what it means actually. So, moving into this final stage, again, we're setting the scene for our subsequent implementation. Here there is also a flag. There is a flag. Wait a second. Yeah. There is a flag. Aggressor is buyer. We know who aggressor is. Aggressor is order 2. That's the aggressor because we put passive always first. So that's passive one, then the aggressive one. So aggressive is buyer. In the example we have considered, the aggressor is buyer indeed. So suppose that this is true. Say true. Then what does it mean? Then B is aggressor, and because the aggressor is buyer and buyer, which means that B, this person B buys quantity of the given quantity of Ethereum USDT at this given price. It means that how transactions would be implemented. Both A and B have Ethereum wallets associated with, first of all, with Ethereum, and secondly with another coin, which is USDT in this case. So then the transaction occurs in the following way. So because B buys a quantity of Ethereum, therefore from A to B, there is a transaction of quantity of Ethereum. They are transferred from A to B in the Ethereum wallet. And from B to A, B pays with USDT. So from B to A, there is a transaction of quantity times price of USDT. And these transactions should be implemented directly, triggered by our smart contract via the ERC20 API. Because otherwise the smart contract would not be able to execute this type of transaction. So that's why we needed this ERC20 or its younger brothers standards, so that the exchange, once a transaction happened in the matching engine, would be able to initiate the transfer of funds immediately through our blockchain. That's what we'll have to implement. And in order to see the technology of how to implement it, from next time, we'll go into Solidity in more detail. We are done for today. Thank you. Any questions, please? Okay. If none, thank you. And I
Thank
think
you.
we are done, and till next Tuesday, when we discuss Solidity in more detail. Okay? Start discussing. Thank you.